Hi, I'm Tapasweni. I work with Mapbox, and today I'm going to speak about Sparky, the Firedog incident response as code. You'd have seen that three of us from Mapbox have talked about different cool stuff that we do in platform team. It's important that I first speak about Mapbox as part of this talk and the subject. So Mapbox, very obvious, we create maps. We have mobile SDKs. We have Mapbox Streets. We have different services. We support navigation. We have geocoding, where you can search for any address. And we have Mapbox Studio, where you can design custom maps. So all these are front services that Mapbox supports for their users, for the developer community. Mapbox platform, we are in 5 different continents, 11 countries, 9 isolated regions, and 60 edge locations. So this is all platform. I work in the platform team. So the important part of working in the platform team is to make the infrastructure performant globally so that all the services are seamlessly available worldwide. And all these services are, which I just described. So we have a lot of services running, and platform team is the first set of people who will face if anything goes wrong. Important part of working in platform team is to face alarms when things goes wrong. And when there is an alarm, we have a structure where there is a pilot, we have co-pilots, we have different escalation policies, and after second escalation policy, we will have all the platform team on the third level. And we have a lot of different services, as I said. Many of them are customer facing, but many of them are also internal. We do a lot of internal processing services for which, again, platform team is responsible for. We use AWS as our infrastructure, and we have different clusters, and we have different clusters alarms. We have different scale up, scale down alarms, and we have set up a lot of alarms on service level. For all these, for these alarms, we use PagerDuty as a service. So this is like when we get an alarm. So we get an alarm, let's talk about when there was no Sparky. When we get an alarm, we get it on an email, and we have different notification settings on PagerDuty, and there is a specific set of steps that we do while working on an alarm. First part is to whoever is on pilot will act that alarm, will acknowledge that alarm, and will start looking into it, what is the cause, and if there are immediate mitigating actions required for that alarm. We first look, for every alarm, we set an alarm description, which would usually be linked to an alarm.markdown file in that specific service on a GitHub repo. That alarm markdown file will be having the name of the alarm, what could cause that alarm, what would be the probable cause that alarm would come, and what can be the solution, and what are the mitigating steps. So these we follow, these 3-4 levels we follow for every alarm that we set up in any of the service, or if it is on a cluster level. When we get an alarm, after hacking that alarm, we start to look at the CloudWatch metrics. We use CloudWatch for metrics. CloudWatch is a service from AWS, and it looks something like this. It's a scaled down alarm, and CPU utilization. It's not like that important, but when we get an alarm, we have first thing we do is to go to CloudWatch and look for such an alarm. We see the different metrics, how much it crossed, what was the threshold, and we set the threshold. We are the people who, the platform team, or who knows the service, who knows how much request count or can affect that CPU utilization, or can cause a spike in CPU utilization, or needs a scale down or scale up. We understand that service, and we set it accordingly. We set the alarm so that before customer seeing it or customer getting an issue, we fix it, we mitigate it, and we resolve the alarm in the platform team without any service getting to know about it. So the first step is to look at the CloudWatch metric and understand different things that happen. For example, what was the request count which caused that CPU utilization hike? What was the healthy host count? How many different new hosts or EC2s, or in simple words, Linux systems came when that alarm came up? How much went down? What was the CPU utilization? What was the memory utilization during that alarm? CloudWatch, Amazon provides a lot of different metrics for all these, and we first try to observe and get the understanding of the situation which caused that alarm. After understanding that, as I said, that we always have a alarm.markdown file which has concrete steps that we need to follow while working on an alarm. That will also include the mitigating steps. So we then try to follow and cover all those steps and do the mitigating steps at the earliest, and also write down what we did. So when we solved an alarm, we try to answer all these questions in a PagerDuty note, which is on the right end. We write why the alarm was triggered, mitigating actions were performed, if they were performed, what were they performed, and root cause and the contributing factors and how they are determined, why the incident was resolved. If we looked at any CloudWatch metrics or Sumo logic graphs and any relevant tickets and customer impact. As one of my colleagues shared, that we use Sumo logic for logging. And after CloudWatch metrics, there's an important part that we make. For example, CloudWatch graph would tell us that there was a 5xx, but we don't know what was that xx. So to figure it out, we run a couple of CloudWatch queries, which also would be written in that alarms.markdown file associated with the alarm that came up. And we will follow those specific steps to find out all the answers and resolve an alarm. From the time it was triggered to the resolved state, we follow a specific number of steps, and people who work repeatedly on specific alarms if the services are not new, and mostly the important services that are customer facing don't change those alarms often. People who work on those alarms repeatedly understand, and there is a repetition every time we are working on that alarm. There is a manual process, there is specific steps that everyone is following, and there are new findings. There could be different request count, there could be different, there may be a connection failure, there may be S3 outage, there could be anything, but to find out, to mitigate, we are following a specific number of steps and specific steps which we have already written down. Be it in be it in some documentation for that alarm, be it in Slack conversation that we did while working on that alarm, and the most important, that we write on the PagerDuty note while resolving that alarm. So the basic important part, before working on Sparky, we realized that we have something that we don't need to put a lot of human effort in working on an alarm and resolving it. So we started thinking in direction, what if we don't need a human to work on such alarms, and which are more often? There is something that we set the thresholds, and at times we just figure out that maybe we need to increase the threshold, maybe we don't want to now alarm at this situation, but everything we write in such a format that I shared before, which is again existing in the PagerDuty note. We started to go in the direction, and we built something as Sparky. What Sparky does is provides a persistent SNS topic and which provides a lambda function which then connects with the PagerDuty on per team basis. Let's say a team is responsible for 4 services. They would be associating their stacks, their service, their GitHub repo, and their production or staging stack with a specific Sparky stack. Sparky's API is an SNS topic that any service can connect its CloudWatch alarms to. Everything we set up is a CloudWatch alarm, and we want to make sure that it goes not in different emails, but on in one escalation policy with a one specific service or Sparky. Sparky is a published NPM module, so it's very easy to set it up, it's very easy to clone it and set up a new stack of Sparky. Every alarm that is sent to a Sparky SNS topic is also sent straight to PagerDuty via email. We also set up Sparky JIS so that if Sparky fails, we still be getting the emails, we still be getting the PagerDuty alarms, so that it's not the only single point of failure. What Sparky helps? So as I said that we have the alarms.md file, the documentation for that alarm, what we have to look at, how to resolve that alarm. We try to enrich that, the alarms.md file with Sparky. We are working in that direction, which will help us to build a knowledge base to work on any new alarm that we get. We avoid subscription confirmation upon creation of new stack. When we are working with Sparky, I am going to speak in next few slides how we set up a service with Sparky. When we are working with Sparky, we don't need to care about every stack being subscribed to a AWS SNS subscription, which is very normal. It can happen that while we create a lot of staging and test stack, it can happen that we may forget to just subscribe to it and we may never receive those alarms. But with Sparky, it will not happen, because while setting up the stack, we will write that part while deploying that stack, it will ask us to set up a Sparky stack, to set up an escalation policy, to set up an email where the team wants to get the alarms. It enriches the data associated with the alarm in real time. When we are writing everything in PagerDuty nodes, we also know that we can use that information to work on future alarms and resolve those alarms, and also improves those alarms.markdown files. We aggregate all our team's alarms into a single PagerDuty policy. Also, part of the alarm triage is also to look for sumo logic queries. So we also try to link all those queries with Sparky, so that there would be no space to forget some important information which is very human. It may happen that there is a lot of different metrics that we need to look. If there is a lot of different CloudWatch metrics that we need to look while working on that alarm, and it's very human that we may misremember that. We may not cover all of them, and at times it just happens that when you get that alarm, it would be green. It would be some blip, but in future, after 10 minutes, you can get a higher 5xx or a higher for anything. So it may happen that when you're ignoring at that point, when it's human error that you're ignoring at that point, you may get it at a higher level in future. With Sparky, you're avoiding that human error, avoiding not looking for the information, avoiding not misremembering any steps. You're trying to cover everything and get the root cause analysis. As we write everything that we did in the PagerDuty notes, we also pull out the information to make sure that we have a RCA from the root cause analysis from the PagerDuty notes with the use of Sparky. So Sparky relies a lot on SNS topic, and as SNS is if in simple words, it's from publisher to subscriber. It can have a Lambda associated with it, it can have a SQS associated with it, any subscriber can be associated with it. So from a service to Sparky is SNS and then Lambda and the PagerDuty API. So Sparky sets up the integration between it from the subscriber, from the publisher to the subscriber. Yeah, so as I said, from the CloudWatch alarm, we usually have CloudWatch alarms in our services to SNS, and we will have Sparky Lambda function that is the PagerDuty API integration. From that, it will go to PagerDuty, and some human will look into it, and then we will resolve it. Now, how it works is, let's say we get an alarm, then and it suggests that alarm a human right now. We got an 5xx alarm. There was an elevated 5xx numbers on multiple services. It starts with there were how many number of 5xx were there alarm, how many 5xx were there, which can be easily pulled out from the CloudWatch alarm. The number is present. And then let's say 100% of the 5xx were 504s. This can be easily pulled out from the past queries, past sumo logic queries that were run while working on the same alarms. Then what were those 5xx caused on? What were the endpoints? Was it just on health check? Was it retrieving some specific image? Was it retrieving some specific endpoint? And then if there were any slow requests, or if there were any slow requests, what were they on? And if any APIs are affected, and in the end to figure out if there were any customer impact, which service was affected and what was the level, how much time it lasted for. Setting up a service with Sparky is very easy. When any new service is created, we set up a Sparky parameter, and there we can define the email escalation policy, the email ID to which the team wants to get their email PagerDuty alarms on. We create, usually we have staging and production for any service. So while creating a staging or production, we decide on the email, we link the email, and we create two Sparky stacks relevant for that specific team. Let's say if a team is responsible for 150 services which will trigger some PagerDuty alarm. So they just need to set up 2 Sparky services. If they're having a staging and production stack, which would be staging and production, they can associate different email IDs with staging Sparky stack and production Sparky stack, and using them, they will be writing in their different services, the customer facing services that they're having. So there will be no chance that any of those services will go unmonitored, because every service would have a Sparky staging if there is a staging service, or a Sparky production which if it's a production service, and then in turn those Sparky staging and Sparky production service would be having email to which the PagerDuty alarms would be getting on. What we are trying to build with Sparky, what is the futures for Sparky, is we're trying to score an alarm. So right now what we do is we make sure that it reaches the human, and there is no need of extra subscription, there is no missing of information, there is nothing that user is just overlooking, or it's missing while working on an alarm. We try to make sure that part, but we are not making sure that if there is no, for a specific alarm, we are working in that direction, that if for a specific alarm we need to alarm a human at all. What we are trying to build is, we are trying to score an alarm, score 0 if there is a human intervention required, or score 1, score 0 if there is no human intervention required, and score 1 if there is some human needed to work on that alarm. The open endpoints that we have and the top to-dos that we are working on while building this system to make sure that the repetitive alarm can be pulled out and can be mitigated from the information that we have already existing in our documents, in our documentation, or in the PagerDuty notes, and not alarm, and just send it to a microservice pipeline where there is no human looking at those alarms. And only in specific alarms which we cannot analyze, which Sparky cannot analyze, would be triggered and assigned to humans. Otherwise, they would be not assigned to humans. To work on this, we are working on scoring an alarm where we would see how many errors, plus 5 minutes, minus 5 minutes we received, what is the severity of that alarm, if there was just a 5xx blip, or if it was consistently blipping for some reason and it is just, and how the errors are ongoing. If they are in multiple regions, at times it also happens that while working in an alarm, you would just, in AWS, you would just be looking at some different region, and you just overlook the information, and you will resolve that alarm, and the knowledge base is lost with that, because you did not work on actually mitigating or resolving that alarm. So we are making sure that with Sparky, we know exactly what is the severity of that alarm. If we don't have any information about that alarm, which is already existing, and how many, let's say like how many 5xx were there, how many 500s were there, if there were 5xx, what is the count of different 502s, 503s, or 504s, and rate in turn by turn for all these 5xx's according to the importance for that specific service, which we already know, being the people who build and being the people who understand those services. Then if there were any slow requests, then if we can replicate those requests which were slow, if there was some to some specific endpoint, and what was the first error which caused that 5xx blip, if it was a segmentation fault, if it was something else, and based on all these information, we are trying to rate our alarm, which if it needs any human intervention, or if it can be sent completely in a microservice pipeline and can be resolved looking at all the important information and machine learn using the information and the nodes that we already have existing that the humans wrote already while working on so many alarms. And we finally want to, we finally want to reach at this stage where we know that we have so many, working in Mapbox, we have so many services, and the platform team is responsible for so many different services on escalation policies and pager duty alarms. We want to reach, and while repeatedly working on that alarm, we want to reach on a state where for such alarms, there is no human needed to work on that alarm, and that alarm would be simply rated at 0 and would go to microservice pipeline and being resolved simply by Sparky. And every developer would be happy, like platform team member. Thank you.